We'll get started on the presentation. I want to cover two main topics today. One is the very severe, almost historic drought. And also I'd like to talk about this super El Nino in the Pacific Ocean. This was kind of the peak of the drought in early and mid-April. Here's a map of the southeast from the U.S. Drought Monitor. It's a joint product from NOAA, USDA, and the National Drought Mitigation Center. Been around since year 2000. Anyway, this is what the southeast looked like in mid-April. You'll notice almost all of the southeast is either in severe, extreme, or exceptional drought, which is D4, their highest category, which corresponds to a 1 in 50 year event for most indicators. And you'll see that D4 covers much of North Florida and South Georgia, even into South Carolina. The rest of the southeast is covered in D3, which is extreme drought or a 1 in 25 year event. So that's where we were in April. In the state of Florida, 99% of the state was in some degree of drought, 80% in the two highest categories, D3 or D4, the most since the beginning of this product. We had the first exceptional drought, or D4, since 2012 this year, and it's widely considered the worst drought in Florida since 1998, when we had those terrible wildfires. So how quickly did this drought develop? Here's some snapshots. Last fall, September, we were relatively drought-free across the southeast. A little bit of yellow coloring, which means abnormally dry, but they don't consider that drought. In just a month or a month and a half time, drought quickly developed. You see now we're in D3, or extreme drought, across North Florida and South Georgia, other pockets in Alabama. And we continue to have below normal rainfall throughout the winter and into the spring, where by April 7th, that's familiar to the last graph, a large area of exceptional drought across North Florida and South Georgia, extreme drought across much of the southeast, Georgia, Alabama, and the Carolinas. So what were some of the two of the main, first, let's just take a look at winter rainfall. This is rainfall departures from normal from October 1st through the 1st of May. And you see, you might not be able to read these, but deficits of 8 to 16, 17 inches or more over the winter season throughout the southeast, especially South Georgia, North Florida, South Alabama. And over on the right, this is the historical ranking for this time period as far as rainfall goes. And everywhere you see that dark red number 1, that's the driest such period on record for these weather stations. And they go from North Florida again, the Panhandle, South Georgia, Alabama, up into the Carolinas, all experience their driest winter on record. So what were some of the triggers for this historic drought? Well, one we can point to is the hurricane season last year. Unlike previous years, like even in 2020, we had 7 tropical storm or hurricane landfalls across the northern Gulf Coast, which of course make their way inland and dump a lot of rain. Last year, we had no systems in the Gulf of Mexico or even affecting the state of Florida, none at all. So at this time of year, 30% or more of rainfall can be attributed to tropical systems. We missed out on that this year. But that's not all. When we had a couple very strong hurricanes, Hurricane Aaron, Hurricane Melissa, that took a track up the Atlantic Ocean off the east coast of the United States, which is good news. It didn't make landfall, didn't do any damage, but the flip side is we are on the western periphery of these very strong hurricanes. And on the western periphery, we get sinking air or subsidence, amplified high pressure. It pulls down drier air from continental air from the north. So the passage of these very strong hurricanes offshore can lead to a prolonged dry period here in the southeast United States. And we've seen that time and time again with Hurricane Matthew in 2016, Hurricanes Dorian and Umberto in 2019, even Hurricane Idalia, which made landfall in the Florida Big Bend, but it was followed by a prolonged dry spell after its passage. So we've seen it time and time again. Saw it again this year with the passage of Hurricane Aaron and Melissa, both major hurricanes that stayed offshore. The other contributor, the Pacific Ocean, and I'll talk more in detail later about this whole cycle. The El Nino, La Nina cycle in the Pacific Ocean affects our weather and climate in the southeast. And last fall, we had cold water in the tropical Pacific. It's shown here in this image by the blue shading. And La Nina phase, or cold water in the Pacific, is known to bring us warmer and drier winters here in the southeast United States. And here you can see the sea surface temperature departures from normal, much colder than normal. So it was this La Nina phase on top of the lack of tropical activity that really triggered this historic drought. Some of the impacts really impacted our rivers and streams and surface water, even groundwater across the southeast. Here, again in mid-April, all of these dark red dots are river stream flows that are in their lowest 5% historically. And this is at the end of the winter, which should be our recharge season. So these rivers, streams, groundwater really received very little recharge this year. And we're still dealing with that right now. Some examples, Lake Jackson, north of Tallahassee, every 25 years or so, a sinkhole opens at the bottom of it and empties the whole lake. That happened again this year. Here's the sinkhole in the dry lake bed. Here's Little River Springs on the Swanee River. The water level, it's hard to see, should be up at the top of these steps. Instead, it's just a kind of rapids flowing from the stream into the very low Swanee River. The Santa Fe River north of Gainesville, Florida, completely dry riverbed. We also had significant wildfires across Florida and the southeast this year. This one, the national fire down in the Big Cypress National Preserve, shut down Alligator Alley for a day or so. Another significant wildfire up in the Panhandle in Holmes County, or Calhoun County. Another one was in South Georgia that burned several houses and structures. So we had a very active wildfire season due to this drought. So what's the current status? It's improved pretty significantly. Now, Alabama, Mississippi, pretty much drought-free. South Georgia has greatly improved. Drought still hanging on in North Carolina and coastal South Carolina, also the peninsula of Florida. And here's just a radar estimates of rainfall over the last 90 days or 3 months. Everywhere you see this pink, that's above normal rainfall, up to 8 inches more than normal. So we've seen really good recovery across Louisiana, Mississippi, Alabama, southern Georgia. Not so much the peninsula of Florida, coastal South Carolina, or North Carolina, where drought is still hanging on. So that's kind of where we are now. Now I'd like to look ahead to what we can expect. And I don't know if you've read some articles or seen some headlines. We are in the El Nino phase, which is the better known of the two in the Pacific Ocean. El Nino corresponds to very warm sea surface temperatures, much above normal in the tropical Pacific. These are satellite renditions of sea surface temperature departures from normal for the last two major El Nino events, 1997, There you see the very warm water from the coast of South America all along the equator. Again, in 2015, 2016, we had a major event. Good story for that. We really publicized this event as we saw it developing during the summer of 2015, and we urged growers and farmers to be ready to harvest in the fall and take advantage of good weather windows because the rain that accompanies El Nino was on its way. Either mid-October, early November is when it usually starts and persists throughout the winter and spring. And so we did that. A grower in Headland, Alabama, Myron Johnson, he took this advice to heart and actually purchased a new tractor to help get his crops out of the field. And it was the right decision. He was able to make most of his harvest before the ground got too wet. So where are we now? These are the current sea surface temperature departures from normal. And again, you'll see large red area where sea surface temperatures are 2-3 degrees Celsius above normal already. And this El Nino is continuing to strengthen and grow. So that's where we are now. We are firmly in this El Nino phase, and it will persist through the winter and into next spring. So what does that mean for us? Here's kind of our conceptual model of how these ocean temperatures affect our climate patterns. And they do that source of heat and moisture that's not usually there in the Pacific Ocean, but is during the El Nino phase, transfers a tremendous amount of heat and moisture into the upper atmosphere and affects our jet stream patterns. And during the El Nino phase, it really strengthens this subtropical jet stream, or the southern branch. And storms form along the southern branch. They impact Southern California, the northern Gulf Coast, and the state of Florida. Just very frequent low pressure frontal passages. Winter rainfall is what we can expect during El Nino phase. The opposite phase, which we had last year, the cold water in the Pacific, you get a jet stream pattern more like this. The storm track up the Mississippi Valley leaves the northern Gulf Coast, state of Florida, the southern U.S. warmer and drier than normal, and that's what we experienced last year. So here's, if we take all the past El Nino and La Nina episodes and lump them together and see what the departure from normal for temperature and rainfall is, we get a map somewhat like this. These maps are for the temperature departures from normal. During the El Nino phase, due to the excess cloudiness, rainfall, and storminess, generally a little cooler than normal. I'm not sure that really holds up these days with the whole nation and the whole planet warming. Now it's probably going to be more closer to normal, but generally we get cooler temperatures in the winter during El Nino phase. During La Nina, where it's warmer and drier, here you see the entire southern U.S., northern Gulf Coast, warmer than normal. Now, what's really important, let's look at rainfall patterns. During the El Nino phase, with these frequent low pressure systems, storm passages, frontal activity, you get enhanced rainfall across the northern Gulf Coast, the entire state of Florida, up into the Carolinas. 20 to 30% more rainfall than normal when you have an El Nino in place like we do this year. Like last year, when you have the cold water in place, or La Nina, you see 20, 30% or more less rainfall than normal across the same region. So that's the typical impacts. It doesn't happen every time there's an El Nino or La Nina, but it certainly tips the odds. Maybe 8 out of 10 times, this is what you can expect. So what is the forecast? It's already considered a strong El Nino, and it's forecast to grow into one of the strongest of the century, comparable to 1997 and 2015, 2016. And here's the official forecast. These bars show a 100% chance of El Nino being in place and remaining throughout the next several months, all the way through December, January, February. That's the heart of the winter, and into the spring. So basically 100% chance. It's a slam dunk. We are going to be in El Nino conditions for the next 6 to 9 months. Here are the model predictions, where actually the average of the model predictions show sea surface temperature departures from normal of over 3 degrees Fahrenheit, which would be a new record. And some of the models are even warmer than that. So this is going to be a very, very strong event, one of the most significant events of this century. However, an old professor of mine told me it's very risky to forecast a new record, so we're not going to go that far, but it's very likely that it'll be a very strong El Nino. And why is that important? The strength of El Nino, or just how warm the ocean temperatures get, does not necessarily correlate to more or less rainfall or more impacts. What it does correlate to is more confidence in the forecast that we will have above normal rainfall and cooler temperatures. So it's more confidence due to a very strong El Nino, but not necessarily more rainfall than a run-of-the-mill El Nino. And go ahead. And here's another just graphic of NOAA's predictions. In the dark red, this is the percent chance that it will be a very strong El Nino, sea surface temperatures greater than 2 degrees above normal, 2 degrees Celsius, like I say, on par with 2015 or 1997. 80% chance that it'll reach that threshold by the late fall and winter. So for the other impacts, the excess rainfall, the cooler than normal temperatures, the storminess, that won't really kick in until the fall, mid-October, November, and then last throughout the winter and spring. It really doesn't have much effect on our summertime climate patterns. But it does have an impact on the hurricane season. An El Nino in place is known to create an environment of unfavorable shear over the Atlantic basin. So it's more difficult for tropical storms and hurricanes to organize and form and strengthen. And this year's hurricane forecast reflects that. There's a 55% chance that we'll be below normal in hurricane and tropical storm activity in the Atlantic basin. This is the first below normal forecast in the last 5 or 10 years from NOAA. There's some other factors, North Atlantic sea surface temperatures, rainfall in West Africa. But this El Nino La Nina cycle is one of the main indicators of the hurricane season. So that's kind of good news. Maybe we'll have less hurricanes. Maybe we won't have damaging impacts from a hurricane this year. And here's just some results from a study we did at our center years ago. We looked at all the landfalling hurricanes over a 100+ year period. And it's important that we looked at landfalling hurricanes because prior to 1961 or so, we had no weather satellites. So the historical record missed some hurricanes that just formed in the open ocean and were never really detected. If you look at landfalling hurricanes, they're well documented. It's a better data set. But anyway, the way to look at this is like an exceedance curve. Red is for El Nino phase, blue is for the La Nina or cold water phase. During El Nino, or all 3 phases of the Pacific Ocean, a high probability of at least 1 hurricane landfall in the United States. But if we go out to 2 or more landfalls, there's a 65% chance during the La Nina or cold water phase of 2 or more landfalls, only a 30% chance during the El Nino phase. So basically the probability is cut in half that we'll have 2 or more landfalls just due to the phase of the Pacific Ocean and the El Nino conditions. 3 or more landfalls, it's only happened once during the El Nino, but 40% of the time during the La Nina phase. And this doesn't have anything to do with the El Nino-La Nina cycle. This is more to do with climate change, and due to warmer sea surface temperatures, a warmer, moister atmosphere due to climate change, we are seeing an increase in the occurrence of rapid intensification. And rapid intensification is defined as an increase of 30 miles per hour or more maximum wind speed in 24 hours or less. And we've seen it time and time again in the past decade with all the major hurricanes that have made landfall in the U.S. Both modeling and observational studies show that this rapid intensification is increasing in the past 10 to 20 years. All right, now I'm going to have some fun. I've never really spoke about this. Oh, I forgot this slide. This is what's happening as of this morning with Tropical Storm Bertha. It's really kind of a mess out here in the Gulf. Never really organized or will organize. It's forecast to drift west into Texas. You see, due to northerly shear, most of the rainfall and convection is out over the Gulf and not really affecting us. Here's the 7-day forecast, again showing the heaviest precipitation out over the Gulf. Not really much impact for us. So we dodged a bullet. It never really developed. It's not even a big rainmaker. Oh, I did want to talk about this. There is a connection between El Nino and tornadoes and severe weather. And this is work done by the National Weather Service office in Melbourne, Florida. Due to this more southerly storm track that we get during El Nino, the occurrence of tornadoes in central and south Florida, nearly twice as many during the El Nino phase as during other phases. And 2 of our deadliest outbreaks of tornadoes occurred during the winter in central Florida, February 22nd of 1998, again in 2007, 21 deaths, multiple injuries. Both of these events coincidentally occurred in the overnight hours when people really didn't get warnings, and really they impacted mobile home parks, which are very vulnerable. And 2 years ago was not an exception. We were in the El Nino phase again. This is the May 10th tornadoes that hit Tallahassee, Florida. Here we have 3 separate tornado tracks. 2 of them came together right over downtown Tallahassee. And my house. There's a tree over on the roof. There's a tree that crushed my camper. Yeah, so that happened 2 years ago during the El Nino event. 600 power poles down across the county. That's more than the previous 3 hurricanes combined. All right, let's see. There we go. And a little bit of climate perspective on tornadoes and severe weather. This is a very well-publicized study from a few years ago. Shows that favorable environments for tornado formation is actually increasing over the deep south and decreasing over traditional tornado alley. So whether that's related to climate change or not, the paper doesn't really say that, but we just have noticed a shift in recent decades. All right, I'm going to close with a fun topic that Libby asked me to address, and that's myths and facts about weather modification. Okay, so what are some of the ways weather might or might not be modified by human activity? Cloud seeding and chemtrails. I'm going to go into a little bit more detail on those. Here in Tallahassee, we have the National High Magnetic Field Lab that some people say steer storms around us in Tallahassee. No, it's located right near the radar facility, where if you're too close to the radar, you don't pick up as much rainfall. It's called the cone of silence. It's just the way the radar operates. Has nothing to do with the National High Magnetic Field Lab. And the magnetic field is in an enclosed room no bigger than like your living room. So no, it's not affecting the whole county. There's HARP. It's a facility in Alaska. They use microwaves, and they beam these microwave energy way up into the ionosphere where the northern lights happen, and do experiments on the ionosphere in a very small localized area. But that's not where the weather happens, and it's not affecting our weather at all, one iota. The weather radar network, NEXRAD radar, some people blame that for adjusting the weather. No, it simply measures the reflectivity from droplets, ice crystals, whatever's in the air, bugs, birds. It measures the reflectivity, but it doesn't alter it in any way, shape, or form. Urbanization is a thing. The urban centers with the development, concrete, asphalt, they hold heat, so they are warmer than the surrounding rural areas, especially at night, and they can even influence rainfall patterns downstream of urban areas like Atlanta. That's been published before. But we've gone so far as Florida actually passed a bill last year that prohibits weather modification or geoengineering in the state. It's never happened, never been done, it's not happening now, so we might as well pass a bill to prohibit the Easter Bunny or Santa Claus. But yeah, it's not happening, so that made some news, but it really doesn't do anything. But let's talk about cloud seeding. Cloud seeding's been around since the 1940s or even earlier. A plane releases silver iodide particles into a cloud. It helps the cloud, the tiny droplets coalesce into rain or ice crystal droplets that then precipitate. It is used in the western U.S. Ski resorts use this to help get more snow on the ground. The Southwest and even the Middle East use it some to help enhance rainfall, but it only works on a very localized area. It does not affect the large-term weather systems, and it might increase rainfall by 10% at most, probably less in most applications. So it's not a big weather modifier, but it is used. Actually, back in 1962, NOAA had Project Storm Fury, where the theory was to do this cloud seeding in approaching hurricanes that would help lessen their strength. They tried it with one hurricane, results were very inconclusive, and the whole program was ended in 1983. The other thing I want to talk about is chemtrails. Okay. Here's a picture. Those are contrails. The turbulence and exhaust from airplanes causes existing water vapor at those high altitudes to condense into ice crystals and clouds. They're just clouds. They are not spraying chemicals. They are not polluting our mind or getting us to go along with Big Brother. No, it's simply clouds. It happens when there's sufficient moisture at these high altitudes. These really clear days, you'll notice you'll never see contrails because there's not enough moisture for them to form. So that's my soapbox for that. There was so much chatter on the internet about weather modification and steering hurricanes that NOAA actually issued a statement. NOAA does not engage in any weather modification or engineering. However, things like cloud seeding are supposed to be reported to NOAA before you do them. Also, as far as hurricanes, no technology exists that can create, destroy, modify, strengthen, or steer hurricanes in any way, shape, or form. So no, it's not the Russians. And here's a link to where you can see the whole statement. So with that, I'm going to go ahead and wrap up. Here's some take-home messages. Florida and the greater Southeast experienced almost historic drought over the winter and into the spring. We're seeing some relief, but the Carolinas, Peninsula of Florida, still hanging on to some drought. Lack of tropical activity last year and La Nina conditions contributed to the onset of this drought. We have seen a switch to El Nino conditions this summer. It's already considered strong. It's forecast to be one of the strongest on records, and it will definitely affect our weather fall, winter, and spring coming up. It increases the threat of heavy rain and frequent rain and even severe weather, but it's also known to inhibit hurricane and tropical storm formation in the Atlantic Basin. So we're looking at a less active season this year. And no weather modification projects are ongoing in the southeastern Florida at this time or the foreseeable future.